All right, everyone, let's go ahead and get started with the webinar today. My name is Steven Zalis. I'm the simulation product manager here at CAD Dimensions. So my email is on the screen. If you guys have any questions, feel free to shoot me an email. I'd love to talk about this stuff. But simulation is an important part of the workflow, right? It allows us to do things like test our prototypes virtually before we have to actually commission or build a physical prototype, right? It allows us to do things like virtual testing, optimization, things like that. So in this case, or in this webinar, I should say, we are going to be talking about 3D experience simulation. So what is the 3D experience platform? It's really a collection of tools that allow us to more efficiently collaborate with coworkers, share our data, things like that. The simulation portion of it is modeling, simulation, and visualization technology from Simulia, which is a sister company under the Dassault Systems umbrella, and it's based on the world-class Abacus solvers. It's really, really nice because it's fully integrated with PLM or product lifecycle management and CAD systems. So think of it like being buried in your PDM system, right? If you guys are using PDM, 3D experience platform operates very similarly. So if we make a change to our geometry, we can go ahead and open up our simulation, and SOLIDWORKS or the 3D experience simulation will actually read that in and it will make the changes automatically for us. So it actually improves our workflow. We get a tighter collaboration between product lifecycle management, our simulation, our CAD geometry, and we can get things out the door faster. The third bullet point, it's a simplified application with tools specific for each simulation domain. So we have a couple of different domains in terms of both desktop simulation and the 3D experience simulation offerings, right? We've got structural simulation, we've got flow simulation, we've got plastics injection simulation, and we've got all sorts of stuff we can do with each one of those domains. So when they were creating the 3D experience simulation tools, they broke each of those domains out to define specific applications and tool sets, just like they did with SOLIDWORKS Desktop. And the nicest thing in the last bullet point is it's fully integrated with the 3D experience platform. And we'll see that throughout this PowerPoint, where it makes it very easy to collaborate with coworkers, shareholders, whoever you need to get your data to or your results to. It makes it very, very easy to run through that. So in this PowerPoint or this presentation, I've got 3 key points I want to hammer home on 3DX Sim. The first one is analyze. What can we actually do with this software? And then the next 2, we have collaborate and manage data. So we're going to kind of focus more on the first point, and then we'll wrap back up with the last 2 points. If we take a look at the 3D experience platform, we have several different simulation domains on the platform. And the first one, we have structural simulation, right? So this is the platform equivalent of SOLIDWORKS simulation. And we have 3 levels of desktop simulation, if you guys are unfamiliar. We have simulation standard, simulation professional, and simulation premium on the desktop. The structural domain on the 3D experience platform is very similar. We have several different levels or applications that we can use to access different features. We also have a new capability expanded earlier this month with durability, right? We have fatigue studies on the desktop portion of SOLIDWORKS simulation, so we brought that to the platform. So we can now feed our results into our durability studies to make sure that we have fatigue analysis to make sure that our parts aren't failing prematurely. We also have more specialized domains on the platform, right? We have plastics injection, we have a flow simulation role or a CFD role, computational fluid dynamics, and then the last role is a little bit different because, or the last domain is a little bit different because it doesn't actually directly deal with setting up and solving simulations. What it does is it allows us to take a look at the post-processing data and leverage the post-processing so we can access studies that our coworkers have done or studies that somebody else has done, and we can make design decisions based off of that. So I've got 5 different domains that I'm going to cover today, and we're going to go ahead and start with the structures domain. The first role, or the first segment of the structures domain, is something called structural designer. And this is a really nice intro to both simulation in general and simulation on the platform, because it comes with a guided assistant, and it allows us to walk through the workflow for new users to either simulation in general or new users to simulation on the 3D Experience platform. It will walk us through everything from creating a study to setting up our mesh, setting up our boundary conditions, setting up our restraints, applying material, and then we can go ahead and run the study and take a look at all the different post-processing options available, just like we would on a desktop solution. The nice thing about Structural Designer, if you guys are familiar or already using SOLIDWORKS Simulation Standard, we really only get linear static studies. With the Structural Designer role, we get a little bit more than that. It's a combination of studies from Desktop Simulation Standard and Desktop Simulation Professional. We get linear static stress studies, we get frequency studies, we get thermal studies, we actually get buckling studies as well to see if our parts are going to be failing in a buckling mode. So we get 4 different studies that we can actually look for. Again, linear stress, we can extract natural frequencies, we have steady state thermal results, and then we have buckling results. So we get a little bit more than we would using Desktop Simulation Standard. We get 4 different study types rather than really just one study type. We have our standard engineering connections that you guys using simulation are already familiar with, right? We've got pins, springs, we have bonded connections, we've got rigid body connections, we've got bolt connections, we've got all sorts of stuff to help make our studies more robust and more physically realistic. The really nice thing about the Structural Designer role is that we actually have an automatic mesher. So we don't even really have to worry about the mesh because it's automatically being created in the background. We do have control over the local mesh refinement. We can control our element size, we can control mesh controls on faces, edges, vertices. So we still have control, but the basic mesh is actually automatically being built in the background, and we don't even have to worry about it. Automatically in the assistant, the mesh has a green check, which means that we've already got our mesh built, and then we can go ahead and take control of it if we need to. But the automatic mesher is super nice because we don't even have to worry about it. We can cross that one off the list, and we only have to worry about our materials, restraints, loads, or our boundary conditions, and then we can go ahead and just run it. This is kind of, again, our base level of structural simulation on the platform. There's 4 different levels to structural simulation. So Structural Designer is the first one. The next one is something called Structural Engineer, and it's almost exactly the same, except we get access to 1 more study type. So again, for Structural Engineer, we have our guided assistant to help us walk through the workflow. We have an additional study type available, right? So we have our linear stress still, we have our frequency, our steady state thermal, and our buckling studies from Structural Designer. But with Structural Engineer, we actually have access to linear modal dynamic studies, which means if we are looking for the frequency response of a system or the time-dependent response of a system, we can use Structural Engineer to pull out that information. So all of these levels just simply build on each other, right? So we don't take anything away. The only difference is that we actually add more and more in. So in this case, again, our Structural Engineer, we are adding modal dynamic studies. So if we needed a frequency response, right? If we had like an engine block that was subjected to a series of frequencies and we needed the load response of that, we could certainly do that. Or if we knew we had a time-dependent loading condition, we can use our Structural Engineer to pull out that information. Just like Structural Designer, we have a bunch of engineering connections available. We've got pins, bolts, springs, bonded connections, rigid body connections, and we've got that really nice automatic mesher. So again, even though we're increasing the study types available to us, the automatic mesher will do a lot of the hard work in the background for us. So we really don't have to worry about it. The next level of structures is something called structural performance engineer. And this is where things start getting really, really cool. We have more study types available again. So we've got everything from the previous modules or the previous roles, but now we get into non-linear things, right? We've got non-linear studies where we can do time-dependent loading or pseudo-time-dependent loading. We can access more advanced material models like hyperelastic models. So we could model really complex rubber materials or elastic materials. We can model things like metal plasticity. So if our metal yields, we can model that. We have something called the Material Calibration app, which we'll see in a second, which is really, really nice because it allows us to take the raw test data from our tests, right? We might feed that in as an Excel file or a CSV file. We can actually take that data, and SOLIDWORKS on the platform will calculate our performance curves or our stress response curves for us and calibrate it to make sure we're getting an accurate material response in our simulation. We also have access to more advanced meshing models. So in the first two levels of structures, structural designer and structural engineer, we had only access to tetrahedral or pyramid elements in our mesher, which is what desktop simulation uses, if you guys are familiar with those. With the structural performance engineer, we can actually access something called a swept mesh or a hexahedral element, where we actually can use, again, our swept hexahedral elements, and it's actually more computationally efficient a lot of the time. We have less elements, but we're actually more accurate. So we have full control over our mesh. We don't have any automatic meshing in structural performance engineer. We take full control back over the mesh, but that allows us to build either more complex meshes, or actually we can simplify the mesh using swept elements, and it makes the simulation more computationally efficient versus having to throw a bunch of tetrahedral elements at our solution to get our solution to converge. So structural performance engineer is where we really start flipping the switch and accessing a lot of the Abacus technology that's on the platform, where we can do things like nonlinear studies. We have more advanced material models. We can calibrate our material response to make sure that everything is working as we would expect. We have our advanced meshing models, so we have full control over our finite element model to make sure that everything is just the way we want it to be before we actually submit the solution for, or submit the simulation for a solution. The last role, or the last piece of the puzzle in terms of the structures domain on our 3D experience platform, is something called structural mechanics engineer. This is the full bore unlock, the full keys to the castle of the power of the 3D experience platform. So we have all of our available study types for us. We have linear and nonlinear static analyses. We have frequency analyses. We have either steady state or time-dependent thermal analyses. We have buckling studies, linear dynamics, and we have something called explicit and explicit dynamics. This is where things get really, really cool. And we'll see a couple of examples in a few slides. But the explicit dynamic solver allows us to model super high energy events like impact events, drop tests, crushing, crash tests, things like that we simply can't do, or it would be very, very prohibitively expensive to do on our current desktop solution. The explicit solver on the platform solves these things no problem. We also have access to multi-step analyses, so we can actually sequence our loading, where if we're dealing with bolt fasteners, right, we can do a preload step, and then we can apply the forces or pressures or torques, whatever we have, are going to be applied on our model once the bolts are torqued. So we can actually do multi-step analyses, or we can do thermal structural interaction, right? So we have one step where we heat our assembly, and then we have another step where we can calculate the stress response. So we can unlock the multi-step loadings where I can say, okay, I've got a preload step, I've got an internal pressure step, or I've got a step where I want to take a look at my natural frequencies. Then I want to take a look at the buckling or different things like that. So we can step and sequence our loading however we want to. We can also, I alluded to this before, but we can also use steady state or time dependent loading, where we can do transient thermal studies, we can do true time-dependent nonlinear studies where things are happening or changing very, very quickly. We have a whole bunch of stuff. Again, like I said, we unlock the entire structural domain using the structural mechanics engineer. We have available to us axisymmetry, which is something I use all the time in terms of tech support or just running studies on my own, right? If we have a simplification available to us, it always pays to run it to make sure that we reduce the solve time, we can afford to throw more mesh on our models. Symmetry is always our friend, and structural mechanics engineer gives us the axisymmetry available. And just like before, again, we never take anything away, we only add. We have our advanced material models, right? So we've got hyperelastic models, we've got metal plasticity, we've got all sorts of fancy material responses. And we've got our advanced meshing algorithms, where we can take a look at TET mesh, a swept mesh, a hexahedral mesh. We can do all sorts of really cool things to make sure that we're optimizing our mesh for the problem at hand. We've got our material calibration app here, right? So in this case, we're actually importing raw data right from an Excel file from a test. We can see that we've got our material curve. We can specify whether it's true strain or nominal strain. We can import that into the platform, and we're going to specify that we want a hyperelastic material response. So in this case, we have different potentials in here. We've got the Moody-Rivlin model, we've got the Yao model, and we can see SOLIDWORKS is calibrating and trying to fit the curve as best it can. In this case, we're trying the van der Waals model, and that looks really, really good. But we can take a look at our material stability and say, okay, at this strain rate, the material is actually unstable. So we're going to go back to the Yao model. And in this case, we've got good agreement between the test data and our material curve. We're stable across all ranges. And then we can go ahead and export this material right down here and actually use it in a 3D experience simulation. So we can take all of the raw data, and we can see in this case, in this screenshot, we've got the Yao model constants, right? We've got all the different constants that SOLIDWORKS has calculated from our material data. It did all the hard work for us and gave us a material model that fits, or a material curve that fits our data. So when we use that material in a simulation, we get an accurate material response. So again, this is our material calibration app with structural professional engineer and structural mechanics engineer. It is super, super cool. I love using this to calibrate, again, rubbers, metals, anything we have test data for, we can go ahead and feed this in, and SOLIDWORKS or the 3D Experience platform will generate a response curve for us. The next piece that I love about the 3D Experience platform and structural professional engineer, or sorry, structural mechanics engineer, the full board, is the Explicit Solver, right? The high energy impact problems like a snap fit on the right-hand side here, or the drop test response of this brace on the left-hand side. All of these, or both of these, I should say, would take forever to solve in desktop if they solved at all, right? And with the Explicit Solver on the 3D Experience platform, this is no problem for the solver to handle, right? High energy impact problems like a drop test or a snap fit, they don't even flinch in terms of actually getting the solution for us, right? So the Explicit Solver in structural mechanics engineer is one of the coolest things that has been added in terms of simulation that we actually have access to, in my opinion, right? We've got super really high energy snap fits. We've got this drop test here. We can see as it starts to rebound from the floor, it starts to kind of resonate. We've got advanced material models in here. We've got everything that we need in terms of being able to handle basically whatever we need to simulate, right? And whoops, we'll go back one slide. We can do a whole bunch of things in the structures domain. And I haven't even talked about the plastics domain or flow simulation yet, right? We're still focusing just on structures. We can do things like bird strikes, damage modeling, right? So one of the really nice things about the simulation aspect or the structural aspect on the 3D Experience platform is we actually can now model damage like this. On desktop, the mesh doesn't actually update once it's generated. On the 3D Experience platform, we can actually update the mesh and remove elements that have been damaged too much. And we get results that look exactly like that, where the blade actually starts to fracture. So we can model things like necking, fracture. We can do all sorts of things that we just simply can't do on desktop. We can do, again, super high energy impact things like door crash or a drop test on this prosthetic foot, right? We can go ahead and things like this would be very, very difficult and time consuming to solve on our current desktop solutions, where the 3D Experience platform doesn't even really flinch at it, right? We've got really super complex contacts and buckling of this elastic seal, where this just simply, to define all of these different contact sets in SOLIDWORKS desktop would take forever. We'd have to guess and check and make sure everything's working correctly. One of the things I haven't mentioned yet on the 3D Experience platform is something called general contact, where we can specify one contact condition and it will automatically pick up every surface in the model and use that contact definition, where we don't have to worry about contact sets anymore. We can just specify a general contact. We can say, okay, general, no penetration contact, or just general contact, and let the solver figure out where these faces are intersecting, right? We can do all sorts of advanced deformation, like this square tube being crushed, right? All of this complex buckling phenomenon down here just simply would not be possible in the current desktop solution. One of the other really nice pieces that they added to the platform is the ability to model liquid particles, right? In this case, we've dropped a bottle that's got liquid sloshing around it. This is due to a technology called SPH particles, or smooth particle hydrodynamics, where we can actually model the effect of having liquid inside of our bottle. This example up here, rather than dropping it, we can actually crush the top of the bottle and watch the liquid shoot out, right? We just simply can't do this in the current desktop solution. So we can actually open up a whole new class of problems on the 3D Experience platform thanks to our Explicit Solver, right? We can do sheet metal forming. We can do thermoforming, right? We can thermoform plastics. We can do all sorts of really advanced, high energy impact, high deformation, non-linear problems without much trouble on the 3D Experience platform. So it is a super, super powerful tool that allows us to, again, just grab a different class of problems that were not feasible on desktop. Were very, very difficult to solve on desktop. Moving into the durability domain, they're really kind of add-ons for the structural domain, right? We've got two different roles or two different levels of durability. The first one is simply durability performance engineer, which is structural performance engineer plus fatigue. So all of the studies that I had covered before, we have linear and nonlinear static stuff. We've got frequency, thermal, buckling, and our linear dynamics. The durability performance engineer role allows us to feed these results directly into a fatigue study, just like we would in SOLIDWORKS desktop. So we run one of these study types first. then we can go ahead and feed them directly into a fatigue study. Again, just like SOLIDWORKS Desktop. So the workflow is very, very similar. The advantages is that we have our advanced material models because we're working with structural performance engineer and our advanced meshing algorithms. So again, everything from structural performance engineer carries over, and then we just have the ability to feed those results into a fatigue study to make sure that we're meeting our durability requirements. The next level of durability is exactly the same thing. We have durability and mechanics engineer. And if you've been following the pattern, it's simply structural mechanics engineer plus fatigue, right? So all of the different study types we have available, we have our linear and nonlinear static, frequency, buckling, thermal, dynamics. We have our implicit and explicit dynamics. We have our multi-step, our steady state, or our time dependency. And we can just go ahead and feed those directly into a fatigue study to get our life requirements. We have our advanced material models and our advanced meshing algorithms. So the structures and fatigue, or the structures and durability domains on the 3D Experience platform are very closely linked, just like the study types in SOLIDWORKS Desktop Simulation, right? We have our studies for our simulation, and then we can go ahead and feed that directly into our fatigue model as an event. So just like they would be on desktop, they are very closely linked on the 3D Experience platform. The plastic injection domain and the flow simulation domain on the platform are much, much simpler. They each only have one role or set of applications. This first one, very aptly named Plastic Injection Engineer. If you guys are familiar with the 3 levels of SOLIDWORKS Plastics Desktop, we have Plastics Standard, Plastics Professional, and Plastics Premium. On the platform, they wrap those all up into one role. So we have access to all of the capabilities of Plastics Premium right on the cloud, right on the platform. It's a fully comprehensive plastic injection solution. We can go from fill, pack, cool, and warpage all in one single application. Really, really easy. We have a guided assistant. We can choose which parts to exclude or include in the analysis. We can say, okay, these are my cooling systems. These are my plastic parts. I've got a virtual mold right around the part. And again, we have our guided assistant to walk through the workflow. So in this case, we've got a little bit of a demo here. We can see our assistant on the right-hand side. We're specifying that the white parts are plastic parts. We've modeled the blue parts as our coolant lines, so we can just go ahead and pick right from the graphics area that those are our coolant parts. We've got a virtual mold set up. We can see that bounding box around the parts. We're applying our materials to our plastic. We're applying steel to our mold here. And then we can just go ahead and set up our simulation. We can specify our fill time. We can specify our pack and cool times. And then all we need is our initial conditions, right? We need an injection location at the top of our runner system. And then we're going to go ahead and specify our coolants, inlets, and outlets, because we need to tell the platform or the program where my flow is coming from and where it's actually exiting my coolant line, so we can do all of our heat transfer calculations. So we can see the assistant works our way through and helps us on the workflow, right? We can just go ahead and open up the part. We're going to say, all right, this component is plastic. These components are my coolant lines. This is my mold. We don't even have to use the mold if we don't want to, but in this case, we're running a full mold simulation. So then we can just go ahead and simulate this. We can monitor our simulation, and then we can go ahead and take a look at our results. Each step is broken out just like it would be on desktop, where we can see at the top we have our fill step. We would also have our pack and cool steps, and we can plot different things. All of the results we would get from desktop plastics we get on the platform, right? The temperatures, flow fronts, pressures, fill times, really anything we might need in order to more efficiently optimize either our plastic part or our mold are handled right inside of the workflow. And the same really goes for our fluid dynamics role or flow simulation role. In this case, we've got one role. aptly named Fluid Dynamics Engineer. It is our comprehensive CFD solution on the platform. So everything that desktop flow simulation can do, the platform offering can do, right? We can do all of our heat transfer, we can do rotating regions, we can do all sorts of stuff. But we've got this really nice guided assistant to walk through our workflow. And the advantage of using the platform is we actually get a little bit tighter design iteration cycle, where as the geometry updates, the simulation is going to update right with it. And in this case, we're going to see exactly that. So we're looking at the intake or the exhaust manifold of a motorcycle in this case. So we've got the motorcycle opened up, I should say, on our platform, and we can go ahead and break it out into each subassembly, and we can see all of the different components of each subassembly. In this case, we're looking for the exhaust subassembly, but we can color code each one to make sure we're working with the latest revision. In this case, we're looking for the simulation that we want to open up, and we are going to look for the exhaust assembly. We're going to go ahead and open this up, and this is what we're actually going to be modifying. So we're going to go ahead and create our fluid simulation, and we've got our workflow, right? We've got our assistant. We're going to go ahead and create our fluid domain just like we would in SolidWorks. In this case, it's even easier because we don't actually have to create any lids because we get these abstractions where the platform will actually pop a lid right on the end. We're going to go ahead and specify our materials for our porous media. In this case, there's a filter in there for the exhaust system or a catalytic converter, so we've specified that. We're going to go ahead and define a steady state step. We've got our boundary conditions, right, our inlet and outlet. We're specifying the properties of our porous media. And then all we have to do is go ahead and mesh and run. The mesh is really, really nice because there's something called automatic body fitted mesh, meaning we can press one button and SolidWorks will actually, or the platform will actually read the dimensions from the model and create a mesh that's appropriate automatically. And then we can go ahead and run and visualize all of our different results in here. In this case, we're looking at pressure, right? We've got our iso plots, we've got all of our contour plots, we've got some streamlines in here. And then we're going to go ahead and replace this exhaust by a different revision. So in this case, we've made a design change. We're going to go from revision A to revision B. And if we replace in our simulation, it will update automatically, right? So we don't even have to do anything other than rerun the simulation. We don't have to set it up again. We don't have to do anything like that. We can simply just go ahead and submit the simulation for solving and take a look at the design improvements, right? So we have the freedom to innovate because our design is tied so tightly to our geometry where we don't even have to actually work on setting up a simulation again. We can just go ahead and replace by a different revision, and SolidWorks will take care of the rest, or the platform will take care of the rest. I keep saying SolidWorks. We're talking about the 3D Experience platform here, but it will actually take that information and update our geometry very quickly. The last part of that video that's true for all of the simulation roles, right? The structures, plastics, and fluids is the ability to solve on the cloud, which is a huge, huge time saver where we don't have to deal and make sure our hardware is up to date. We can go ahead and make sure and just submit our simulations for solving on remote servers where we can specify the number of cores we want to use, right? The more cores we have, the faster our solution is going to solve. We could also solve on our local hardware if it's a small simulation or if we're confident in our hardware, right? If we've got a really nice computer, we can certainly solve on our own hardware. But the advantage of doing all of this as a cloud-based technology is it's instantly scalable, right? If we have a solution or a mesh that's really, really large, right? Several tens of millions of elements, we can go ahead and utilize Dassault Systèmes cloud resources and say, okay, I'm going to go ahead and submit this job, and I want to use 64 cores rather than using the 8 cores that are on my machine, and we can scale our solve time appropriately, where we can, again, get faster turnaround time, so we can make design decisions faster. We can do all sorts of stuff like that. So I did want to mention that before we jumped into simulation review, because this role or this domain is a little bit different. Again, we're not dealing directly with any of the simulation roles. In this case, it's more of a post-processing where we can feed the results that we used in the first couple of roles or first couple of domains, and use these to make design decisions instead. So in this case, this role is called Simulation Collaborator, and we can use it to conduct performance trade-offs. If you guys have used a design study in SOLIDWORKS Simulation, this interface is fairly similar. It should look familiar. We can share content with coworkers and shareholders across the world. And the nice thing about the Simulation Review app is that it's actually browser-based. You don't actually have to leave your internet browser. The other domains, the other applications that I've showed off so far, all have a local installation on your machine. So the data is cloud-based. All of the simulation data, the parts files, all of that will live on the cloud, but you actually pull that data onto your machine to run these simulations and set up these simulations, right? We can run them on the cloud, but all of that requires a local install. The simulation review role, or the simulation collaborator role, is all browser-based. So you can actually do everything in your web browser and share with coworkers, stakeholders, shareholders, whoever you need to share that data with. So this next video will also highlight the other 2 points that I had at the beginning of the PowerPoint, right? Our collaboration and our data management. It makes it very, very easy to share our design information, especially in today's climate, right? Today's environment. We've got 6 or 7 different people working on the same project with file-based PLM or file-based lifecycle management. All of the files might live on a central server, they might live in a vault somewhere, and everyone is all over the world, right? We've got suppliers in Asia, we've got modeling specialists in Europe, the requirements manager is in North America, and a lot of this stuff, we have a lot of emails back and forth, right? We need to wait for approval, we need to make sure that somebody's read the email. There's a lot of steps to this process. With the 3D Experience platform, with the 3D Experience platform here, everything is much easier to handle because the 3D Experience platform is really a live platform where everyone gets notified when everything else is happening, right? In this case, we're going to take a look at our emails again, but with the 3D Experience platform, you actually have a notification section where you can have conversations with coworkers, you can set up specific teams to work on different projects, right? We can save our time, we can actually save our money, right? Because everything is accelerated and we can innovate faster and faster, right? So in this case, we're in the Simulation Review app. We've got 4 different versions of our bracket and we want to make a change. So I can say, hey, Ravi, I've got 4 different proposals. Can you please check them and make sure that they're correct? So in this case, he's going to drag all the results into our performance trade-off app, and we can see our requirements on the left-hand side, right? I need my maximum stress to be less than whatever. I need my von Mises stress to be less than. I can pop those out into individual windows where I can make decisions very quickly. And in this case, he's actually voted on the one that makes the most sense, and he's going to go ahead and share this with Christina so she can see exactly what he sees. So from Christina's end, he's going to go ahead and just make her aware, and from Christina's end, she's going to get a quick notification that Ravi has shared a file with her, and she's going to go ahead and open that up, and she sees exactly what he sees. So the collaboration is even faster, right? Because we don't have to put this into a report. We don't have to put this into an email. Everything lives on the 3D Experience platform. So we can have conversations, we can have teams, we can do a lot of our work on the browser where we can make our decisions very, very quickly because we're not jumping back and forth between our internet browser, our email, right? Our calendar, everything is all built into one platform, which makes things really, really nice. And again, that hammers home kind of our analysis, right? Because we have full capabilities of the Abacus solver, where we can do things that we couldn't do in desktop, where we can do things that we couldn't do in desktop quicker. We can do all sorts of things. We've got domains for everything, right? We've got structures, plastics, flow, all sorts of stuff. We've got our collaboration, we've got our data management, everything is cloud-based, so you always have the latest version, really, no matter where you are. In terms of sim-specific value review, right? We've got complex simulations, we've got cloud computing. We don't need to make sure that we have the latest and greatest hardware, because hardware moves very, very quickly, right? You could buy a new computer now, and in 6 months, it's already outdated. So we don't have to worry about keeping up with our IT infrastructure, because we can leverage our cloud computing options. We can communicate our ideas, design changes, and updates very easily, all in one central location on the 3D Experience platform. And with that, we can manage our simulations and all of our other CAD data on the cloud. The really nice thing is, if we need to make a change to our geometry, we can pull our data into SOLIDWORKS that we all know and love. It's the same modeling program. We can go ahead and make our changes, save our data right back up to the cloud, open up our simulation, do a quick refresh or rebuild, and those changes will be easily propagated. Our boundary conditions won't change. We can go ahead and rerun the simulation, and we've got things faster than ever, right? So everything lives on one central place, and we can do different things. We can do our data management, we can do our simulation, we can do all sorts of stuff, all on the 3D Experience platform. So that's all I've got, guys. I'll open it up for Q&As for a couple minutes. Let me run through and check, and then I'll get you guys out of here. All right, the first question I got from Craig: how does the cost model of 3D Experience compare to the desktop apps? That's a great question, Craig. The really nice thing about the 3D Experience platform is, because it's a live platform, right? You're paying for access to a service. The pricing model is a little bit different. So rather than paying upfront for the cost of a SOLIDWORKS license and then grabbing, the yearly maintenance for whatever product you are working on, the 3D Experience platform is more like a lease, where you can pay for, I think there's 3 months and yearly access. So you can pay quarterly if that's something you'd rather do, right? If you need it for a big project, or you need it for something coming up, you can pay quarterly, or there's a price yearly. I'm not sure exactly how the price breaks down versus specific simulation products, right? I know off the top of my head, I believe 3DX Plastics is a little bit cheaper than the desktop version for 1 year, but you are paying basically the full price yearly, because you're leasing yearly, versus the desktop solution where you pay most of it up front, and then you pay just a yearly kind of maintenance fee or yearly rent. So the pricing model is a little bit different. If you want more details, go ahead and shoot me an email, and I will get the appropriate information to you. Will this PowerPoint be available to share? Chuck, if you want to email me, I can certainly send it over, and you can go ahead and distribute. All right, guys, looks like we don't have any other questions, so go ahead and sign off. I'll give you guys about 5 minutes of your day back. If you have any questions that do come up, feel free and shoot me an email. Again, I'm always down to talk about this. Check out our website, submit a tech support case if you would like more information. Again, we got plenty of resources to help get your questions answered. So go ahead and enjoy your lunch, guys, and I will be in touch.